Hi, and welcome to the third of 4 videos for section 2.7. As you can see from the timestamp, this is another really short video, but I've done this specifically for this section because there's a few different topics, and if you have to go back, it's not the easiest of subject material, inverse functions, one-to-one functions. So I wanted you to have these shorter videos where you can go back and find them easily, review the material easily if you need to. So in video 2, we talked about inverse functions. What's the definition? If we're given 2, how can we show that they're the inverse of each other? In this one, we're actually going to be given a function and have to determine what the function is, what the inverse function is. So the steps for how to find the inverse of a one-to-one function. So first off, we're going to write y equals whatever the function is. We're going to add a y into the equation now. So we might have had f of x equals x to the third. Well, now we're going to write y equals x to the third. We're going to get rid of the f of x. We're going to replace it with a y. Whoops, number 2, not number 3. We're going to solve for x, and this is if possible, so sometimes it won't be, so we're going to have this function, we're going to have y equals whatever the function is, and we're going to move all the pieces around so that we end up with x equals something all by itself. And then step 3, we're going to switch x and y. So anywhere we have an x in the equation, we're going to change it to a y. Anywhere we have a y in the equation, we'll change it to an x. And now that we have that, this equation that we just created is y equals f inverse of x. So, let's look at a couple examples here. I want to find the inverse of f of x equals 3x minus 2. So, step 1, get rid of the f of x and change it to a y. So I have y equals 3x minus 2. Step 2, I'm going to solve for x. So I want to get x by itself. So what do I have to do? I have to add 2 to both sides. So I get y plus 2 equals 3x. And to get x by itself, I need to divide both sides by 3. So that gives me x is equal to y plus 2 over 3. And now that x is by itself, I'm going to switch all the x's and y's. So here's an x, I change it to a y. Here's a y, I change it to an x. So I get x plus 2 over 3, and this is my inverse function. So f inverse of x is equal to x plus 2 over 3. Now let me say one thing here too. So you may have already been taught this, or if you go to the tutor lab, they may teach you a little differently. Sometimes step 2 and 3, people change them. So once they write this y equals 3x minus 2, they change the x's and y's at this point and then solve for y. Doesn't matter, you're still going to end up with the same thing at the end. It's just the way I teach it is solve for x, then change all your x's and y's at the end. But if you change them first and then solve for y, that's fine. Now, it's an exam. I still have 10 minutes left. I want to go back and check my work. Is there any way to determine whether this is the right answer or not? The answer is yes, right? Because if I plug my inverse function into the original function, I should get what? I should get x. So let's try that. So I want f of the inverse piece, x plus 2 over 3. So that's what? That's 3 times x plus 2 over 3 minus 2. So the 3's cancel. So I get x plus 2 minus 2, which is what? X. Bingo. So we know that the inverse function, I'm saying, well, this is my inverse function. I can actually check it, plug it in. As long as it comes back to being x, I know that I'm fine. So let's look at one more example here. So let's say f of x is equal to the square root of x plus 3. And I'm going to add something in here. State the domain and range of f of x and f inverse of x. So if we were to draw, so first we have to know, is this a one-to-one function? And it is, because what? F, the square root of x plus 3, this is going to be a function that looks like that. So it passes the horizontal line test. Any horizontal line test is only going to hit it once. And so what's my domain of f of x? Well, it's everything from -3 up to infinity. And how about the range? So the range of f of x, well, that's any potential y value that I'm going to get. And that's what? 0 up to infinity. So, given what I told you at the very start about inverse functions and the domain and range, I can already tell, or I can already state, what the domain of f inverse of x is, and I can state the range of f inverse of x. And it's what? They switch. So the domain of f of x is the range of the original function, and the range of the inverse is the domain of the original. So that means the domain of f inverse is going to be 0 to infinity. And the range of the inverse is going to be whatever the domain of the original was, which is -3 to infinity. And that's why I sort of stopped when I was giving you guys the definition and pointed out how critical that is, that piece of information, because I don't even have to know what the inverse function is. I can already tell you what the domain and the range of the inverse function are. But now let's go ahead and find this. So that's it, state the domain. And then also let's find f inverse of x. So we do what? We say y equals the square root of x plus 3. And I need to solve for x. So what do I have to do? I have to square both sides. So I get y squared is equal to x plus 3. And to get x by itself, I need to subtract 3 from both sides. So y squared minus 3 is equal to x. So now I switch my x's and y's, so that means x squared minus 3 is equal to y, which is the inverse function. And again, so we have this x squared, but our what? Our domain is only going from 0 to infinity, because we saw earlier that a parabola is not a one-to-one function. But because our domain is only going from 0 to infinity, in that case, if we were to draw this, so if we were to draw this function with the domain 0 to infinity, the range -3 to infinity, it's going to look something like, let's see, it'll look something like that. So starting at -3 and shooting upward. So come on back. We're going to actually do some more of this in video 4, graphing of these inverse functions. But the important thing here, domain and range, they flip-flop on us. And then finding the inverse function, the 3 steps we had learned earlier. So again, come on back, we'll look at video 4, and that'll be the last of the videos for this section.